So we're going to think about the titration, and if we could watch that titration with our molecule glasses on. We're going to put some molecule glasses out here, right? So those are like cool guy molecule glasses. And I don't know, maybe we don't like those. Maybe we want fashionable chick molecule glasses. Those are cool. Oh, maybe we want some funny molecule glasses. Those are good too. Whatever molecule glasses you want are fine. So here, this is a picture from your book that shows a strong acid being titrated with a strong base. So the acid here is hydrochloric acid. So we have hydrogen ion and chloride ion. And remember, a strong acid, these are really going to be fully dissociated even when we add them to the flask. And so the flask would look like this initially. Sodium hydroxide. Sodium is shown with a purple sphere, and hydroxide is an OH, and they're stuck together, right? It's a polyatomic ion. And then they react to form water. And then we have separated sodium and chloride ions as the product over here on the right. And so at each point in the titration, we can see what's going on. So if we think about the sodium hydroxide is what's in the burette, and then of course we have HCl in the flask. And we're going to think about what's in the flask. We're going to play a game of, as the titration proceeds, we're going to play the game of what's in the flask. What's in the flask? I don't know. So if we start with the first point, here, initially, what's in the flask is pure analyte. And so all we have is H plus and Cl minus floating around, waiting to be titrated. All along here, what happens is some of the hydrochloric acid has been converted into sodium chloride. And so some of the H plus is gone because it's been neutralized to form water. The water they have eliminated from here. They're taking out anything. They just took the water out for simplicity purposes. And so one of these H pluses is gone because it has reacted with the OH minus that you dripped in, and it's reacted to form water, which has now disappeared from their image. So you have some sodium left over because the sodium was here, part of the hydroxide. And so all along here, you have what looks like this here. Okay, and it just depends on how many, whether or not you have sort of in the 10 mil mark, you would have an excess of hydrochloric acid, and then you're getting less and less and less and less and less as you get up to the equivalence point. And all the way up to the equivalence point, just before the equivalence point, you have a little bit of excess H plus, which controls the pH. And then at the equivalence point, you've exactly consumed your HCl analyte, which means that all you have left in solution is sodium chloride. So that is this point here. And then beyond the equivalence point, you have excess sodium hydroxide. So that is this excess base point here at the end. Now, if we continue to play what's in the flask, if we think instead about our weak acid analyte, and again, the glasses on the flask, molecule glasses, this is what we would see in the flask at various points in the titration. So initially, what we would see is just the analyte, which is shown here as acetic acid. So that's this point in the curve. So initially all you have is acetic acid. Now along the transition point, before we get to the equivalence point, you have a mixture of some acetic acid is left, that's what you see here, and then some of it has been neutralized to form acetate ion. So we have a mixture all along this green part here. We know that they will be equal in concentration at the midpoint. We know that before the midpoint, we will have excess acid, and after the midpoint, between the midpoint and the equivalence point, we will have excess base, but they will both be present all along this green part here. Now at the equivalence point, we only have the conjugate base left in the flask. That's this third box here where it's just acetate ion. And after the equivalence point, we have excess hydroxide that you see here. And so probably the best take-home message from the titration calculations is that you can identify what's in the flask at each point along a titration curve.